Hey everyone, my name's Maxwell Murphy, and today I'm going to be showing you how to take a sine vibration test specification, maybe it's from your client or customer, and how to put that in VibrationVIEW. So let's go ahead and jump in. I'm going to look at my sine vibration test. I've just got that right here on the right of the screen. The test calls for performing a sine vibration test on the device under test. So this could be a battery, a satellite, a cell phone, a laptop, whatever it is that you're shaking. Okay. We're going to sweep from 5 hertz to 2000 hertz at a sweep rate of 4 octaves per minute. And then we're going to maintain an acceleration of 1G using 2 control accelerometers, and we're going to place them per the supplied figure. So typically in your test specification, you would have a figure that shows you where to place the control accelerometers. And then we're going to use averaging of the control signals as our control strategy. And we're going to try and maintain that control signal within plus or minus 3 dB of the demand. And the demand being 1G, 5 to 2000 hertz. Now, there's a caveat here. The individual control signals may deviate from the demand by plus 6 dB and minus 24 dB. So this is pretty typical, actually, whenever you're doing any kind of low G sine vibration sweep. You kind of have a little bit of leeway on your minimum acceleration, because a lot of times you kind of hit noise and some other kind of weird harmonics within your device. So totally fine. So use 2 response accelerometers and place them on the device under test per the supplied figure. And we've got one more instruction here: annotate the highest resonance peak on the response accelerometers. So we're going to perform a sine vibration sweep on our device under test, and the test engineer, the operator is interested in annotating those resonance peaks. Go ahead and select the test. So I'll hit edit test, and from here I'm going to just start going through most of these tabs. A couple of these are a little out of scope, but we can kind of touch on them briefly. So my start amplitude, it's going to be 1G peak. That's pretty good, right? So it's already per my specification, so wonderful. And then my start frequency is going to be 5 hertz. And I want my end amplitude to also be 1G, and then it's going to be 2000 hertz as my ending frequency. Now, notice that this is a one-step test. I could insert, additional steps if I wanted to sweep up and then sweep back down. That's also an option, but in this case, I'm only sweeping one direction. Okay, so let's go ahead and check out the scheduled tab. I'm sweeping up from 5 hertz, and I'm sweeping at 100%. So I could change this if I wanted to 50%, but there's nothing in the test that calls for that. And then let's check out the sweep rate. Yeah, so this is not always specified in customer specifications. From my experience, your typical sweep rate is going to be anywhere from 1 octave per minute to 2 and sometimes 4. Really just depends on how much content your engineer or test engineer wants to capture. All right, so we'll go ahead and select the parameters tab. This is all pretty default. In my experience, I've shaken hundreds or maybe thousands of devices. I've never really had to tweak this at all. So now we're in the limits tab. So our control limits, we're told, hey, we want a tolerance of plus or minus 3 dB. And that's what this calls for, so great. And then we've got some abort caveats. I'm going to go ahead and leave them at plus or minus 6 dB, and then we can adjust them as needed. I would recommend that 100%. There's no reason to expand if you don't need to. And then in my experience, and this is kind of a little out of scope, but the startup drive limits, I've never seen above 10 volts per G on the max system gain. The guys over at Vibration Research will be able to walk you through any of these questions here. Okay, I'm not going to really touch on pre-test here. Right, so for my channels, we're told per the specification, use a control strategy of 2 control accelerometers. So we've got those selected here. And right, we've got individual control limits. And again, I'm going to leave those as plus or minus 6 dB. And then how are we going to establish our control strategy? It's averaging of the selected channels. From my experience, I have used maximum of selected channels, but most commonly it's averaging. All right, and now just a kind of pro tip here when it comes to data, I would very much recommend saving every 10 seconds, every unless you have like an hour vibration test, maybe every minute. You really can't go wrong with collecting more data. What I would not recommend is doing one at the end of every test. So that would kind of just look like this. So you're going to save data to disk at the end of every test. Would not recommend that, only for the reason being if something should go wrong, you don't really have any data to kind of fall back on. So I'm going to do at the end of every one sweep, and then every 10 seconds. And here's another pro tip. I can select 10S, and that's going to just put 10 seconds. Similarly, I could do 10M. I'll do that, and that'll be 10 minutes. So just a neat little feature that Vibration Research put in. So I'll make it be 10 seconds. Great. And tables, I won't touch on this in this video. Calcs and resonances, yeah, it's okay. All right, so we're ready to start the test. I've already got my, and again, this is in demonstration mode, so I'm not operating a real shaker, but this is what you would see out in the field. I've got my control accelerometers connected, and I'm ready to start the test. Okay, so, but I almost forgot. We need to be looking at our response accelerometers because, obviously the engineer, the test engineer is interested in analyzing those responses. And it's important for us as the operators to also be observing. And when anything kind of looks a little out of place, then of course, we can abort the test and then troubleshoot anything we need to. So I'm going to go up here to edit graph, select that. And right now I've got one graph that is plotting acceleration versus frequency, and I have my control signal and of course demand on there. And my graph 2 is the text window. So I'm going to insert another graph after graph 1. And I'm going to plot the acceleration versus frequency. And the response accelerometers will be channels 3 and 4. So I've applied that. So, and I'll go ahead and remove the control. And I'll just select this and hit the delete key. Pretty straightforward, and then I can leave the demand on there. That just kind of gives me an idea of where it should be versus where it is. So I'm ready to start the test. Okay, so as it's running, I'll kind of talk to this a little bit. It looks like our response accelerometers are staying, within right on the money for 1G. So as we start to shake this to higher and higher frequencies, we might see a little bit of resonance peaks, and that's totally fine. Now, if you notice up here, I'm only looking at the control signal. Well, our control signal is being averaged by 2 control signals. So I'll show you in just a moment why it's important to display both control signals, or the individual channels that make up the control. All right, so it looks like my response accelerometers are hitting a peak. And I'll go ahead and annotate those. So it looks like this is channel 3, and I can just select it here, or I can select it over here. And I'm going to hold the shift key and then hit the insert key. And that's going to go ahead and just put that right on the plot. And similarly, I'll do that for channel 4 as well. I'll hold shift, and that just snaps it to that resonance peak, and hit insert. Okay, so I've got an issue here, channel 1 minus abort. Oh, so remember, in our test that we built, the abort limits, we only made it down to minus 6 dB. So let's go ahead and expand that a little bit to 24 dB. All right, I'll just do it for both. So we'll hit apply. And now if I just do that, I didn't actually look at anything. So how about I analyze it a little bit and just see, oh yeah, channel 1 did go to, that minus abort limit. So I'll go up here to edit graph, and in graph 1, and again, I'm going to look at my individual channels that make up the control. Okay, this is great. So I've got an abort code here, or a stop code rather, channel 1 minus abort. And if I just select here, yeah, it looks like my channel 1 was definitely going down. So that lines up perfectly with what the stop code was. So now I'm going to just go ahead and hit start test, and I'm going to continue it. And again, this is just telling me, hey, this isn't a real test. So no problem. And it'll auto size. Perfect. So this is why it's super important to also analyze or display or observe even your individual control channels that make up the control. Because notice my channel 1 is dipping high up here, but channel 2 is dipping low, but averaging they're fine. Well, if you went to 100 Gs versus 1 G, your average might be great, but your individual controls will be really out of whack. So that completes the test. It was 2 minutes, 23 seconds, not bad. And then, of course, we are going to sell this to our customer for what they want. So I'll hit the print button here, and then just hit print. And we'll print to profiles. That's fine. You can select whatever file directory you want. You could be or it could be a company network drive. Maybe you have some folders that are kind of buried down that you can then place them there. So yeah, so you can save it wherever you want, and it'll be displayed as a PDF. That concludes this video. Thanks for watching. If you have any questions at all, feel free to reach out to us at vibrationresearch.com.